Okay, I'm going to go over the practice test for Module 5, which is all about numerical expressions. So the first question on this test just asks you to write 3/4 times 3/4 times 3/4 times 3/4 using an exponent. So the only thing you would need to do here is 3/4 to the third power, since there are 1, 2, 3 of them. However, to keep this from looking like 3 to the third divided by 4, we would need our parentheses around the 3/4. So this is going to be a 1-point problem, and I'm going to give you half a point if you forget those parentheses. Because if you forget those parentheses, that might change how you evaluate, which is going to be a couple of the next questions here. Question 2, which expression is equivalent to 7 to the power of 3, or 7 cubed? Select all that apply. So remember, 7 is our base, so that's our number that repeats. Our exponent is 3, so that means we have 7 times 7 times 7. Our base repeats 3 times. 1, 2, 3, which is letter E. It does not mean 7 times 3, and it does not mean 3 7 times. Remember, our numbers are not reversible there. Now, the second thing we need to look at is how to evaluate it. So if I pair these together and do 7 times 7, I get 49, and I'm left with the times 7. Remember, this little dot is another way to write a multiplication sign. So I'm going to have to figure out what 49 times 7 is. It should either be D, B, or F. Let's see which one it is. So 9 times 7 is 63. 4 times 7 is 28. Plus 6 makes 34. And F would be my other option. So number 2 will be a 2-point problem. There are 2 correct answers here. So 2 points, 1 point for each correct answer. Number 3, we are now evaluating the expression. Remember, evaluating the expression just means finding the answer. So when we find the answer to a numerical expression, we always use our PEMDAS. So remember, parentheses, exponents, multiply and divide in the same step, and add and subtract in the same step. So when I look at this problem, I see parentheses here. There are parentheses here, but remember, like we talked about in number 1, it's just to show us that it's the 1/5 to the second power. So we're going to do just this set of parentheses. So I have 4 plus 2 to the third. So once I get inside the parentheses, I continue with my order of operations. So E stands for my exponent, so I'm going to start there. 2 to the third power. Well, that would mean 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So in this parentheses, it now says 4 plus 8, which I know is 12. So I'm going to replace everything in parentheses with the 12. And that means I have 1/5 squared. Remember, the dot means times 12 plus 6. Continue with my order of operations. I need to work on my exponents next. Parentheses are done, so exponents it is. 1/5 to the second power. So that means 1/5 times 1/5, or 1/5 2 times. When I take 1/5 times 1/5, I'm going to get 1/25. So I'm going to replace this with 1/25 times 12 plus 6. Exponents are now finished. Multiplication and division. So the only multiplication and division that I see is this right here, which means I have 1/25 times 12, or 12 over 1. So that's just going to be 12 over 25. So 12 over 25 plus 6. And that is just my mixed number broken down. So I'm going to get 6 and 12/25 for my final answer. And this will be a 2-point problem. The first point I'm going to give you is that you can follow the order of operations. So I can see that first you did your parentheses, second you did your exponents, you multiplied and divided, and then added. Your second point is going to come from that you did the math piece correctly. And number 4 is the same type of question, just with a different numerical expression. So you evaluate again, we're just going to find the answer. So again, following the same steps, parentheses, exponent. Multiply and divide in the same step in order from left to right, and add and subtract. So again, start with those parentheses. I see this in parentheses. 4 times 8 is 32. So I'm left with minus 5 squared plus 12. So parentheses are done. Move on to exponents, which is this right here. So 5 squared, remember, is 5 times 5, which would give me 25. So I have 32 minus 25 plus 12. Moving on to multiplication and division, I don't have any of that, so I can skip over that step. Add and subtract, but remember, I go in order from left to right. So here's the first problem I run into. 32 minus 25. If you can't do that in your head, work it out on the side of your paper. We've got to borrow. So 12 minus 5 is 7. 2 minus 2 is 0. So I get 7 plus 12 is my leftover. 7 plus 12 equals 19 for my final answer. So again, this is going to be 2 points. Point 1, you follow your order of operations. Point 2, you do all your math correctly and get yourself to the correct answer. Right? Moving on, we'll continue to number 5, which again is an exponent question. So it says take 0.5 to the 4th power. So first thing I need to know is that 0.5 to the 4th power means 0.5 4 times. 0.5 is my base. 4 is my exponent that tells me how many 0.5s do I want to write. So the first thing I'm going to do is pair together these 0.5s. So I'd have to do less multiplication here for myself. So when I do 0.5 times 0.5, I'll work that out over here. I get 5 times 5 is 25. 5 times 0 is 0, but plus 2 makes the 25. And then I really don't have to multiply by the zeros. You can if you want, but it would just give you a line of zeros. So that means I need 1, 2 decimal spots. So 1, 2. So this is going to be 0.25, which means it's 0.25 over there. So now I just need to multiply to find my final answer. So I'm going to take that 0.25 times 0.25. 5 times 5 again is 25. 5 times 2 is 10, plus 2 is 12. 5 is done. Hold its place. We're going to multiply by the 2. 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 makes 5. We add these together. and we get 625. However, when I go to do my decimal, notice there's 1, 2, 3, 4 spaces. And I only have 1, 2, 3 numbers, which means my fourth space is going to be one of those zeros. So my answer here is going to be 0.0625. This is also going to be a 2-point problem. Your first point comes from that you understand that this exponent means take the base 4 times. And then your last point, or your second point, comes from that you multiply correctly. Number 6. Number 6, remember we said we were going to take out this part where you had to pay to host the bake sale, because on your actual test that will not be on there. So we don't want to practice it. We did do a problem like that on our apply. That would be kind of an extended problem or above proficiency question where you would need to do that. So here's what we were doing. For the Henryville Elementary 6th grade is having a bake sale to raise money for the St. Louis trip. The cost of various baked goods is shown in the table. There were 52 donuts, 65 brownies, and 25 Rice Krispie treats sold. What was the total amount of money the 6th grade raised? So here's what we found out from this problem. We are selling items for a fundraiser. We are selling donuts, plus we are selling brownies, plus we are selling Rice Krispie treats. Now, I need to replace those with actual numbers from the problem. So when I look at donuts, in my text, it told me that I had sold 52 donuts and my donuts cost $1.50. So I remember from last module, when we're dealing with cost, we're going to take our cost, so $1.50 times 52, plus, now I'm going to move on to brownies. Brownies, there were 65 brownies, and they cost me $1.25. So I'm going to take $1.25 times 65. Now my Rice Krispie treats, 25 of those for $1.75. So I'm going to say $1.75 times 25. So your first point comes from that you can follow these directions and write an expression that explains how much money the 6th grade would raise. Your 2 other points from this problem. So number 6 is going to be 3 points total. So this is point 1. Your other 2 points are going to come from this down here that you can now evaluate it. So again, these 2 points are given because you have followed the order of operations and you have done your math correctly. So order of operations says I'm going to do my parentheses first or multiplying first if you choose not to do the parentheses. So I'm going to evaluate and find out how much do I make when I sell the donuts, how much do I make when I sell the brownies, and how much do I make when I sell the Rice Krispie treats. So I'm just going to do some work over here. 1.5, $1.50 times 52. Multiply through by the 2 first. Let's see, that's 10. 2 times 1 is 2, plus 1 is 3. Hold your place value. 5 times 0 is 0. 5 times 5 is 25. 5 times 1 is 5, plus 2 makes 7. When we add all this, we get 7800. Looking at my decimals, I see 2 decimals in this problem. So I would have 2 decimal places here. So I would replace this part of the numerical expression with $78. That's my donuts. Now looking at my brownies, I'm going to have to take that $1.25 times the 65. And again, multiplying by the 5 first. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 5 times 1 is 5 plus 1 is 6. 5 is done. Hold its place. 6 times 5 is 30. 6 times 2 is 12 plus 3. So I got 15. And then 6 times 1 plus 1 would make 7. So again, now I've multiplied by both, so I'm just going to add these numbers together. Look at your decimal places when you started. You need 2 spaces, so we're going to make sure our answer has 2 decimal places. And I would replace this set of parentheses with 81.25 plus, now I'm going to work on the Rice Krispie piece. So the Rice Krispies cost me $1.75 times 25. 5 times 5 is 25. 5 times 7, 35 plus 2, 37. 5 times 1 is 5 plus 3 is 8. Done with the 5, so hold its place. 2 times 5 is 10, carry the 1. 2 times 7 is 14, plus 1 makes 15. 2 times 1 is 2, plus 1 is 3. All right, add all these up. And then again, 2 decimal places. So I replace this with $43.75. Okay. Next up is the last step of this problem, which is to add. Now we talked about that you could just add these two and then add this one on, or if you prefer to add them all 3 together so that you can only add once, that's okay too. So remember though, when we're adding our decimals, we have to keep our decimals all lined up. So that's 78, even though it has no sense, we need to make sure those decimals are lined up there. So when we add, we're getting our price correct. So 5 plus 5 plus 0 is 10. We've got 7 plus 2 plus 1 is also 10. Carry the 1 over. Let's see, 8 plus 1 is 9, plus 1 makes 10, plus 3 is going to make 13. Carry the 1. And then we have 1 plus 7 is 8. 8 plus 8 is 16. 16 plus 4 is 20. So I'm going to get a final answer of $203 here. So again, the fact that you can follow your order of operation and get these numbers and then add correctly. So the math piece gets you 1 point. Following your order, because that's a big part of our numerical expression lesson, is being able to follow those steps. And that takes us to the next part of our chapter, which is the greatest common factor. So what we had to do for problem number 7 now is, what is the greatest common factor of 12 and 32? So we talked about 2 ways to do this. One way to do this is to make a list. One way to do this is to make a factor tree. And lots of you prefer the factor tree way, which is just fine. So you can choose on this problem. So if you choose the factor tree, remember, it doesn't matter what you decide to pick. If you didn't pick 2 and 6 and 3 and 4, you picked 3 and 4, that's okay. We're looking to get our prime numbers. So I know 3 times 2 is 6. So here's what I got for my factor list. I got 2 2s and a 3. Now you should get 2 2s and a 3 no matter what numbers you picked here. Okay, the next one, let's factor down 32. So let's see, I'm going to go 4 times 8. Factor down my 4 here. So I've got 2 2s Factor my 8, gives me another 2 and a 4. So I got to pull that 4 apart. Wow, that's a lot of 2s. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Now I'm going to look and see what do they share. Remember, we only want to look at what they're sharing. So I see this one has 2 2s. This one has 2 2s. Well, this one doesn't have any more 2s, so I can't share these. And this side doesn't have a 3, so I can't share that 3. So the only thing they share are these 2 2s. So we say 2 times 2 is 4. The greatest common factor is 4. So this is a 1-point problem that you can find your greatest common factor. Number 8 is also greatest common factor. It's just put into a story problem now. So Kelly has 15 Reese's and 21 Twix that she's using to make treat bags. She wants to make the greatest possible number of bags with both types of candy bars, and she wants each arrangement, so each bag, to have the same number of Reese's and Twix in it. So part A, you can use greatest common factor to work out this problem. So part A, another way we can do greatest common factor is making the list. So what this asks you to do is write down your factors of 15 and 21. So they already say 1 times 15 will get you there. Well, I can't, excuse me, I can't do 2 times anything and get to 15, but I can do 3. I can do 3 times 5 and get to 15. Now, the only thing in between 3 and 5 is 4. And 4 times nothing gets me 15. So that is all my factor list. So this is 1 point that you can get your factor list. Factors of 21. Well, 1 and 21. It's an odd number, so I know 2 doesn't work. 3 does, though. 3 times 7. 4 doesn't work. 5 won't go into 21. 6 won't go into 21. These are all my factors. This is 1 point. Now, looking at my factored list, it asks me to answer part B. What is the greatest common factor of the number of Reese's and Twix? So when I look, they both share 1. They both share 3. They don't share any of these other numbers. Okay? They share 1. They share 3. 3 is the biggest number they share. So the greatest common factor is 3. This is your last point. So number 8 is going to be 3 total points. You get a point for each of your factors, and then you also get a point for coming up with your greatest common factor at the end. Number 9. Number 9 is using that distributive property. So it already set your greatest common factor. It already pulled it out and said your greatest common factor is going to be 21. And we need to figure out what is 21 times 2 1/7. We've worked out problems like this. We had to make it an improper fraction and then go through and multiply. But it says that we want to do it using the distributive property. So remember, what the distributive property means is I can break apart a mixed number. So I leave my 21, but I can break apart this 2 1/7 into 2 plus 1/7. Just like back here on number 3, when I had 6 plus 2, 12 25ths, I can make it 6 12 25ths. This is the same thing back here, except it's already pushed together. We now are separating it. So remember, distributive property says I need to do it to both of them. So 12 times 21, so 12 goes to 21 goes to the 2, and 21 also gets multiplied by the 1/7. So when I look at this, I know 21 times 2 is 42. You may have to multiply this one out to the side if you can't do that in your head. And you're going to get 21 over 7. 21 divided by 7 is 3. So I have 42 plus 3, and I'm going to get an answer of 45. So this is going to be my 2 points right here. First of all, that I knew that I could break that apart, and then I could get to an answer I could solve once I got it broke apart. Part B is 1 point. So this is a 3-point problem also on number 9. And it's just explain what you did. You're welcome to use the numbers there, or you're welcome to explain how to use the distributive property. So what I would write was step 1. I'm going to break apart the mixed number. Step 2. I'm going to distribute. Remember, we talked about that means we're going to pass out 21 to each piece, because 21 was already pulled out as my greatest common factor. And then the third thing, I guess I should say each piece and multiply. And the third step is just to add those pieces together that I got. So again, question 9 is a 3-point question. This is a breakdown of how I'm going to score each part of that. Question 10 is also a distributive property question. Question 10 says, use the distributive property to write an equivalent expression. So this has not told you your greatest common factor. So the first thing we're going to have to do is come up with that greatest common factor, and then, write an equivalent equation. So here we go. Step 1, we're going to break apart 24 and 60. I know lots of you like to use the tree method, so that's what I'm going to model. If you like the list, you're welcome to make your list. So let's see here. I know 6 times 4 is 24. Again, if you want to start with different numbers, that's okay, because you should get the same factor list. And this would be 3 and 2. So I have a 3 and I have 2 2s. Over here, 60, well, what pops into my head first is a 6 and a 10, which I just broke 6 apart over here into a 3 and a 2. A 10 can be 2 times 5. So now I have a 3, 2 2s, and a 5. So I'm going to look at what do they share. Well, they both have a 3. They both have 1 2. They both have a second 2. But that's where they stop pairing. So that means they share a 3, a 2, and a 2. So I'm going to multiply all these together. 3 times 2 is 6. 6 times 2 is 12. So what that means is my greatest common factor is 12. So this is going to be 1 point right here that you can come up with your greatest common factor. Your second point on this problem is that you can write an equivalent expression. So here were my 2 numbers, 24 and 60. So if I pull 12 out, 12 times what could get me back to 24? Well, that would be 12 times 2 plus 12 times what could get me to 60? Well, that would be 12 times 5. So my equivalent expression would look like this. Pull out a 12 and then do a 2 plus 5. And this would be your other point. So this is a 2-point problem as well. Remember, order does matter. You can't flip your 5 and 2 around because then you would have 12 times 5 first, which means your 60 would be your first number. So I wouldn't give you your whole point if you did that. I would count half off. All right, and the last 2 questions on your test deal with least common multiple. The first one, number 11, says, what's the least common multiple? Remember, multiple means we're multiplying, we're getting bigger. So I'm going to make a list of all my multiples of 6 and 15. So we count by 6, we count 6, 12, 18. Let's see, 6 more would be 24. 6 more would be 30. And that's where I'm going to stop because I know 15 2 times is 30. And I want the smallest, the least number that they share alike. So my least common multiple is going to be 30. And this is just a 1-point problem that you can create your list and find the number that's the smallest that they share. And number 12 is, how do you use the least common multiple example out in the real world? So number 12 says, on every 5th visit to McDonald's, Mike receives a free pop. On every 8th visit, he will receive a free fry. After how many visits will Mike receive a free pop and a free fry at the same time? So 5 visits, we receive a free gift. Every 5th visit, every 8th visit. So I'm going to count by 8 first, and here's why. I know how to count by 5s pretty easily. I know if it's a multiple of 5, it ends with a 0 or a 5. So when I run into one of those numbers when I'm counting, I'm going to see if that works. So let's see. 8, not a multiple of 5. 16, not a multiple of 5. 24, not a multiple of 5. 32, not a multiple of 5. 40, aha, I think I found it. Let's check. 5, 10, 15, 20, 25, 30, 35, 40. 40 is the first time they share a number. So that means 40 visits is how long it's going to take before they get the soda pop and the free French fry at the same time. This is going to be a 3-point question because you had to first pull out the 5 and pull out the 8. You had to know that those are the numbers you were doing least common multiple of. Up here, they told you which numbers to use. So I'm going to give you a point for pulling those out and writing your list. And then coming up with my answer is also going to be 1 point. So these are your 3 points for this problem. This test is worth a total of 25 points. Remember, a good thing to do is practice those problems that you miss. Good luck studying, and let me know if you have any questions.